This is Rges Pre-Algebra, and the lesson is 1.10, Greatest Common Factor. We have already talked about greatest common factor one time in lesson 1.7, and we gave you a tool that will always work for identifying a greatest common factor. To review, let's think of the numbers 12 and 18. Break this down to its primes, which I would do either by tree method or by multiplying by primes. Once you're familiar with that, you can also kind of just do it in your head. Okay, 12 is 2 times what? 6. 6 is 2 times 3. And that's kind of how I do it, just mentally. 18 is 2 times 9, and 9 is 3 times 3. So I just do that prime division in my head. Now, to find the greatest common factor, now remember what greatest common factor means. It means what is the largest number that divides evenly into both 12 and 18. And if you can even do that in your head, do it in your head and skip the steps, at least right after you've been tested on it, and I know that you can do it. But normally I try to pick numbers that aren't quite that obvious in your head, though it's hard to be honest, at this level without getting very complex with your numbers. Okay, so what do? I'm looking for what are the ones they share. What are the ones in common? Well, they have 1, 2 in common and 1, 3 in common. Even though 12 has an additional 2, the 18 does not. And even though 18 has an additional 3, the 12 does not. So we do not include the others. And when I multiply that out, I get 6. Okay. So that would be the way we find the greatest common factors. Now recall that before, what had you done? You had said 12 equals 1 times 12, and 2 times 6, and 3 times 4. 18 equals 1 times 18, and 2 times 9, and 3 times 3, but I would not repeat the 3. Of those, the ones they had in common were the 1, 2, the 3, and the I missed 3. I said 3 times 3. It's 3 times 6. And the 6. The greatest number of those was the 6. Okay, so this was the first method you learned. And the second method is what you're learning today. Break it into prime factors and identify what are all the prime factors they share. Sometimes they will even repeat. For instance, they might both have 2 2's in it. Let's say the number were 36. I would have an extra 2 in there. And so if they have 2 2's that they share, then go ahead and include both those 2's. Down below, let me show you another example. If we have 15 and 20, we break those to their primes. 15 is prime factors, right? 3 times 5. 20 is 2 times 10, and 10 is 2 times 5. So my greatest common factor would be what they share. They don't share a 3, they don't share a 2, they share only the 5. Now again, I might have looked at these two numbers and said 15 and 20, what's the largest number that divides evenly into them? And I might be thinking, okay, 15 is 3 times 5, and 20 is 4 times 5. The largest number that divides evenly in is 5. And that's, again, just fine. The next idea in 1.11 is called the least common multiple. What I'm asking here is what is the smallest, the least number, what is the smallest number that both can multiply evenly into? So let's say I have the numbers 6 and 8. Well, there are a couple of different ways I can do this. One of the ways is I can count forward by sixes, 6, 12, 18, 24, 30, etc. I can count forward by eights, 8, 16, 24, 32, and I could have really stopped with the 24 because I noticed, oh, whoa, there's one they share. So the least common multiple is the number that both 6 and 8 can be multiplied by some number to equal 24. This is going to be exactly what we use when we start identifying the common denominator when we work with fractions. So I could do that. Some people find it cumbersome to count up by larger numbers, so here's another way to do it. Take my prime factors of 6, that would be 2 times 3. My prime factors of 8 would be 2 times 4, which is 2 times 2. And then what do I do? Looking at the prime factors, my least common multiple, I'm going to think through each prime. Let's think through the 2. 2 is a prime, our lowest prime. Which one has the greatest number of 2's? That one. How many 2's? 3. So this would be 2 times 2 times 2. My next prime that I see in either of these is the 3. How many 3's? 1. Okay, so I am looking for the product of how many times each factor, like 2's a factor, 3's a factor, each prime factor is found in a single one of the numbers, either the 6 or the 8. Notice what I do not do is use 4 2's. I have 3 2's in the 8, 1 2 up here. I don't add them together. I'm just looking for the largest number in either one. Multiplying it out together, you get 4 times 6 then, and 4 times 6 is 24. So I got 24 by just counting out by 6's and by 8's, and I get 24 by using prime factoring. Now let me point out one more idea with this and another example. Let's say I had 12 and 30, and I wanted to find the least common multiple. Break it to its primes. You could use the tree method, the prime division method, or you could do the mental method that I'm kind of illustrating. This is 2 times 6. I keep that number 6 mentally and break it down again. 6 is 2 times 3, and I stop when I only have primes. 30 is 2 times 15, thinking of 15 because it's not prime mentally, that can be broken down to 3 times 5. Again, my least common multiple would be what? The number of 2's, the greatest number of 2's in any one would be 2. The greatest number of 3's in any one would be 1. And the greatest number of 5's in any one would be 1. Again, multiplying that out, any choice, I can multiply in any order. I'm going to do 10 times 6 or 60. What am I saying? If I have the number 30 and the number 12, what is the least number that I could multiply that into and that into evenly? 30 would be, of course, 2 times 30 is 60, and 12, it would be 5 times 12 is 60. Okay, but 60 is my least common multiple. Do not confuse that with the greatest common factor. The greatest common factor of those two would be the things they share in common, right? They share a 2 in common, and they share a 3 in common. And so the largest number that divides evenly into both 12 and 30 is 6. Okay, so these are almost like opposite ideas from one another. Make sure you see the difference between these two ideas. Now, the only other thing I'd point out to you is this. What if I had the numbers, let's say 8 and 24, and I'm asking for the least common multiple? Well, notice 8 goes into 24 evenly. 8 times 3 is 24, so 24 would be the least common multiple. If one number divides evenly into the other, the larger number would be the least common multiple. Looking at those two again, 8 and 24, if 8 divides evenly into 24, what would be the greatest common factor? The 8, because it can't be a number larger than one of them, right? So that would be the greatest common factor. Make sure you study those two ideas also, and that will help you a great deal when you start looking at these things mentally.